Ask an old-style model a problem with a few steps, and it answers in one breath. The first words it lands on. Pens, 3 for $5, 12 of them, a $50 note. It blurts 45. On problems like this, that's exactly where it slips. A reasoning model does something different. Before it commits to an answer, it thinks out loud on a private scratchpad. Watch it work the same problem. 12 pens, 3 for $5, so that's 4 groups of 5, $20. You paid with 50. 50 minus 20 is 30. Only then does it write one short, checked answer. $30 in change. The step-by-step is called a chain of thought. One honest caveat, though. That scratchpad shapes the final answer, but it isn't a perfect transcript of what's happening inside the model. Treat it as working out, not a confession. The scratchpad is also where the model corrects itself. It might start down one path, then catch a slip, stop, and back up to try another. That self-checking is most of where the accuracy comes from. And it doesn't have to bet on a single line of reasoning. It can explore several at once, in parallel, and keep the answer that most of them agree on. More attempts, then a vote. Here's the key idea. All of that thinking is just more tokens. The model's weights never change. It simply does more work at answer time. Researchers call this test time compute. A standard model might spend under 400 tokens on a question. A reasoning model on the very same question can spend close to 7,000. That extra effort is the thinking budget, and tokens cost money, so thinking literally has a price. And on hard problems, spending pays off. Give a reasoning model more room to think, and accuracy climbs. On competition-level math, scores can jump 30 points or more. Problems a standard model simply can't touch. The cost is real, though. Matching a top model this way can take 10 to 100 times as many tokens. More thinking, more right answers, up to a point. Because past that point, more thinking starts to hurt. Push the budget too far, from about 1,000 tokens to 16,000, and accuracy can actually fall from 87% down to 70%. Look at the wrong answers, and they're often the longest ones. The model second guesses a correct step and talks itself out of it. And on easy questions, all that deliberation buys a point or two for a much bigger bill. It's an upside-down you too little thinking misses. Too much overthinks. So, where did the skill come from? Nobody handwrote the steps. Instead, the model was given problems with checkable answers, math that has to add up, code that has to pass its tests. It generated many attempts at each and earned a reward only when it reached a verified correct answer. That's reinforcement learning from verifiable rewards. Do it across millions of problems, and something striking happens. The model teaches itself to pause to check, even to say, wait, let me try that again, all on its own. The long reasoning wasn't programmed. It emerged. So, treat thinking like what it is. A budget. Switch it on for the hard problems, off for the easy ones. Spend it where it pays. That's the whole game.